Hello, and welcome to the Global Genes Rare X Frequently Asked Questions video series. My name is Josie, and I'm a team member of the Global Genes Rare X Research Program, as well as a genetic counseling master's student at the University of Washington. In this video series, I will be addressing some of the most frequently asked questions about what it means to share your genetic data with the Rare X platform and how that data can help support rare disease research. In this video, I will be addressing how you can view your curated genetic test report data and in what ways this data may be helpful for you. Let's start by reviewing what curated genetic test report data is exactly. Curated genetic test report data is genetic data that has been reviewed and structured in a way that is easier and more efficient for researchers to use. We curate data from genetic test reports because the structure of these reports varies widely between labs, making the information difficult to compare and use effectively for research. Researchers value curated genetic data because it standardizes information found on genetic test reports, making it much easier to compare information across participants and recognize patterns in the data. By organizing this data in a clear and consistent way, our curation process helps researchers use the information more effectively to support rare disease research. Let's think about a couple of examples. Most people with a genetic disease know the gene associated with their condition, and many people know the specific genetic variant. For example, you may know that your child has a CHD2 related neurodevelopmental disorder due to a specific variant in the CHD2 gene. But researchers sometimes need more detailed information. One example is a reference sequence used, or the baseline genetic code that researchers use as a comparison against an individual's genetic data. There are different versions of the reference sequence, which have been updated over time as scientists learn more about the human genome. It's important for researchers to know which version of the reference sequence was used because different versions can lead to variations in how genetic variants are identified and interpreted. Researchers also value information regarding how a variant was inherited, such as whether it was passed down from a parent or if it appeared as a new genetic change in the individual. New genetic variants that occur for the first time in a child and are not inherited from a parent are called de novo variants. De novo variants are common in neurodevelopmental disorders. When a variant is de novo or new, it is more likely to be the cause of disease. Knowing if a variant is inherited or de novo also helps researchers to better understand disease mechanisms and know how the specific gene functions. So, where can you find this curated genetic test report data? You can find this data on your dashboard in the Completed tab under the Surveys/Studies section. You'll want to press on the three dots to the right and then press View in order to view the curated data. At the bottom of this page, you will see a toggle for most recently completed version only. Make sure that this toggle is turned off or appears gray rather than blue. This will ensure that you see the curated data for all genetic test reports that you have uploaded. As a participant, there are certain details in your curated genetic report that might be of interest to you and may provide useful context if you are exploring clinical trials or treatment options. For example, the protein effect type, which describes how the genetic change impacts the way the resulting protein is made. Some trials and treatments are designed for individuals with only a specific type of protein effect, such as a nonsense variant, which means that the genetic variant stops the protein from being made. For example, there's a clinical trial testing a treatment for a very rare skin disease called epidermolysis bullosa. The treatment is specifically designed to bypass or read through the stop signal caused by nonsense variants. So the trial is only accepting participants who have at least one nonsense variant in the targeted gene. We can see this in the inclusion criteria at the bottom of this slide. For a more common condition, called Duchenne muscular dystrophy, a therapy approved in Europe also targets nonsense mutation. It works in the same way by helping the body read through the faulty stop signal caused by the nonsense mutation, making it available only to individuals with this specific type of variant. Another example of information you may find valuable in the curated report is the location of your variant. For instance, in Usher syndrome, a rare condition that affects hearing and vision, there is an ASO-based experimental therapy that is directed at variants only in exon 13 of the USH2A gene. Exons are sections of a gene that provide the instructions for making proteins. Exon 13 is one of these specific sections. For individuals with Usher syndrome, only those with disease-causing variants in exon 13 are eligible for trials using this ASO approach. It can be difficult to determine the exact range of genetic variants that occur within exon 13 because that can change based on the methods used by the lab. However, nearly 20% of individuals with Usher syndrome type 2 are estimated to have at least one genetic variant in exon 13. Common exon 13 variants include C.2299del-G, which is prevalent in the US and parts of Europe, and C.2802T-G, which is common in Taiwan and China. The data our curators collect can help determine which participants have variants in this region, which provides valuable context for experimental therapy eligibility. That's all for this FAQ video, and I hope that you found it helpful. Be sure to check out the other videos in this frequently asked questions video series, where I'll be answering more questions about sharing your genetic data and supporting rare disease research. Thanks for watching.